IVA spacesuit or the intravehicular spacesuit is the second measure to save their lives. The first is the pressurized module. So if anything wrong happened to the pressurized module, the re-entry capsule, if any leakage happened, the IVA spacesuit can save their lives. So before the launch, they must close their helmets, close the face mask, and check if the airtight sealing is efficient.
Are they able to conduct that check
yeah,
themselves,
they will
or
check,
do they need to go through a system?
This do not
no,
need
they
a much.
have to do it themselves,
They will check and report to the ground. Only with this check conducted can they ensure we can go further into the next step.
So safety has been considered as a priority to the astronauts.
Oh,
Yes,
absolutely.
exactly.
At full stages, even before they board the rocket itself, and also in the capsule, we rely on the escape tower, which can lift them out of the rocket and land in a safe area. Once the escape tower is ejected,
Jettisoned.
we have the capsule that can also return to Earth with a parachute. Yeah. So at full stage, we have the safety of the astronauts. At any time they can abort the mission, they can come back to Earth safely. So we had experiences before with the Soyuz rocket that they have already traveled about 100 kilometers above the Earth, and they had an issue with the rocket, so they had to return with the capsule itself. So they made it, but it was a rough ride.
Midway through the launch,
yes, midway through the ride. It's
returned.
It's about less than 10 minutes of the launch.
That's what I
And
mentioned,
this
the MS-10 mission, Soyuz MS-10 mission.
And this would be something that would be programmed into as a sort of a backup plan already in the launch plan.
Look, this is another rotational platform has already been opened. We can see more parts of the fuselage, of the core stage. Now even we can see the China national flags on the payload fairing.
Sorry, so just remind us again, what are the dimensions of the capsule that these astronauts are sitting in?
Well, that's what we see just now is the payload fairing. The diameter of the payload fairing is 3.8 meters, the diameter.
3.8 meters.
And for the capsule, the diameter is about 3.35 meters. And also...
that's you're talking about the diameter from the outside, right? But for them,
it is the biggest one. But for the re-entry capsule, the size of the re-entry capsule, the biggest diameter is only about maybe 2.3 or 2.4 meters. So that's much smaller. So the advantage of use 3-module design with orbital module, the re-entry capsule, and the propulsion module is that the advantage you can build a very, very small re-entry capsule. So it's much easier. But you know that today the trend has already been changed. For the new generations, like our Mengzhou spacecraft, the diameter is much bigger. So it makes it possible that with a bigger diameter, the inner volume is already big enough. We do not need any orbital module. So comparing with 3-module design, with the new generation, we can adopt the 2-module design. And with the 2-module design, you know that almost all the new generation spaceship of all other space capable nations adopted this 2-module design because it has a bigger diameter, although it brings some challenge for the re-entry, but also have some advantage because with a bigger diameter, you can also have a wider and more convenient inner volume, and also you can have more instruments recovered. So it is useful for saving the money in retrieving the re-entry capsule.
The 3 meters in diameter is sort of the space between us right now sitting around here, but it looks much more snug, exactly, because they have so much equipment in there as well, right? It's completely crammed. I didn't see the astronauts go in with any luggage, shall we say.
It's already there.
It's already there.
In the orbital module. You can see that there are shelves everywhere, and the cargoes just put well and fixed well in the shelves. So today, you know, that it is very interesting. The role of the orbital module has already a little bit changed. You know that during the years before, they do have the function that it is a habitable area for the astronaut because, you know, as I mentioned, the re-entry capsule is too small, too narrow. It is not very comfortable to stay there for days because so in the old missions we conducted several days of mission. For instance, for the Shenzhou-19 mission, the 2 astronauts, Fei Jinlong and Ni Haisheng, stayed in outer space for 5 days in this very narrow space. But today, you know that we've already adopted the fast rendezvous docking. Only we need about 6 hours. So today, the role of the orbit module has already changed. So we hope that we can have more, because it doesn't matter to stay in such a narrow space, because only a very short period, only 6 hours.
Has it ever been used as an airlock?
No, we only use it as an airlock during the Shenzhou-19 mission.
Yeah.
But today we do not, because you know that in Shenzhou-19 mission we do not have other choices.
Because you have to go out to outer space for EVA, then you have to have an airlock.
Yeah.
So people can depressurize and then go out and come back.
And they
so use that as an airlock in the previous missions.
Yes. But today you know that with the fast rendezvous and docking, it's okay for the astronaut to stay in so narrow place for this short period. So we can have more chance to install more cargoes inside the orbit module. We've already seen that.
Yeah. They have modified the module. The expert mentioned that the 19 mission they have enlarged the volume so that it can put more cargoes, maybe more apples in board.
This is very meaningful for the biological experiments. Some living things. You can put that together with the astronauts
like
inside.
the fruit flies. Yeah, so Mr. Xu, you were saying earlier that there would be another supply cargo ship going up there
next month.
Yeah, 2 weeks, right?
It's roughly mid-November.
Mid-November.
They're planning to.
And would that be the only supply ship then for the Shenzhou-19, or would be expecting another one a bit later?
The Tianzhou-8 cargo spacecraft will both support the Shenzhou-19 crew and the Shenzhou-20 crew, because you know that the interval we launch a Shenzhou spaceship is 6 months, but for the launch of the Tianzhou cargo spacecraft, the interval is 8 months. It's different. So for Tianzhou spacecraft, it will support 2 crews.
Okay, so the one going up next will be for this crew and the next.
Shenzhou-20.
Okay.
That's but cool. they have plenty of things to unpack, because they have already got the service module, the orbital module fully packed with bags, and so in the coming 2 weeks they're going to use that time to do a handover job with the Shenzhou-18, and also do a lot of unpacking and packing for the Shenzhou-18 to come back. So they have to do, put the experiments, results, and everything into the capsule of the Shenzhou-18 return capsule, and then wait for the cargoes to come. So it's a time sequence that allow them to work in this period of time with a carefully planned schedule.
It doesn't sound like they have much downtime at all. It's get there and it's out to work straight away, isn't it?
Now look at the screen. At this moment, all the rotational platform has already been opened. So we can see the whole fuselage of the launch vehicle itself. You can see the slim body. But still, I should emphasize, at this right moment, they still have some arms connected to the launch vehicle, usually in yellow color. You can see that. And also on these arms, there are cables and pipes connected to the launch vehicle. Still, at this moment, T-minus maybe 20 or 30 minutes counting, still we use the power supply, the electricity from the ground. So to stay, as Yansong has mentioned, to save the storage battery on board our Shenzhou spacecraft and our launch vehicle. And several minutes later, we will have a very critical step, as we already discussed, the transfer of the power supply from the ground to the vehicle itself.
Yeah, you can see the 2 umbilical cords.
Yes, that's what I mentioned, the arms. Look, in yellow color, connected to the launch vehicle.
Well, we have 20 minutes or so to go until launch, and let's check in again with our reporter Sun Ye, who's there at the Jiuquan Satellite Launch Center. Sun Ye.
骄阳很不容易啊，在如此临近火箭发射的时候，我们找到了一名火箭专家来告诉我们现在火箭的状态怎么样。我们这回请到了徐珊珊老师，他是中国航天科技集团的专家。那徐老师告诉我们，
please let us know about the latest situation about the rocket.
截至目前吧，
So and also till now what kind of the work we have done.
给大家报告一下。
So let me report to you, and right now that everything goes well and the rocket actually is functioning well. Right now we've finished all the preparation work for the control system, and also the telemetry work actually is all in the program. So as we know, for the Long March 2F actually is famous for its safety and reliability, and also is improving itself. So this time, what kind of the modification we have? So for this time, compared to the Y18, so we have improved 23 items, and we talk about the structural system and also the techniques, and also for the sealing and also the tightness, and also actually we improved the process of launch. Previously it's need 37 days, right now it's shortened to 30 days. Although it's a save that 7 days, a week time, but for the whole system it's improve our efficiency, but also we could tell that for the old system of the rocket, actually we showcase our confidence and our understanding about the whole system. And also we are very glad and also very excited, just within 20 minutes we will see Long March 2F Y19 will send Shenzhou-19 to the space.
All right, so yeah, thank you so much to you and your guest there. We'll check in with you again later. So lots of improvements made to every new edition of the rocket. Mr. Xu, what would you say are, do you think, some of the most impressive improvements made this round?
Well, I think the engineer has mentioned not only the launch vehicle itself has been improved with 20 plus items, but also
23, right?
Yeah, but also the Shenzhou itself, which is the launch vehicle and the capsule are manufactured by different academies. The launch vehicle is manufactured by the Chinese Academy of Launch Vehicle Technology. The capsule is manufactured by Chinese Academy of Space Technology. So all of them are working together to improve the efficiency, the reliability of the launch vehicle. We know there are changes. If you put a change to, for example, software, there will be a 7% chance that you will have another hiccup with the whole complete system.
7% chance. Yeah. That's very exact.
Yeah. So if you put a change into the system, you have to consider all aspects. And this has been experienced by the Europeans Ariane 5, because Ariane 5 is using the Ariane 4 launch vehicle softwares, but the software was modified in such a way that lots of unfitted software functions were remained in the Ariane 5 launch vehicle. So that had a catastrophic failure for the first launch. So when you make changes, you have to be very careful that this affects the other sides of the complete design. So they made very careful improvement. I think it's very important to increase the efficiency of the launching campaign. She said from 37 to 30 days. That means a lot of manpower saved, and lots of travels, and a lot of logistics, and lots of technical support has been saved. So I think that is a great improvement to the launch vehicle and the whole system for a more efficient launching campaign.
Actually, Professor Yang, there's something I wanted to ask you earlier when we were talking about the IAC. So the theme this year was responsible space activities for sustainable development, right? So how does China's rocket and the Tiangong space station, how does that all fit into this?
Well, you know that during this IAC, we also have many events related to the China's manned space activities and lunar explorations. To have a sustainable future, you know that the leaders of China aerospace, including Mr. Li Guoping and also Mr. Lin Xiqiang, although it's online. Okay, T-minus 15 minutes and counting. So this is also another milestone for the launch. So the commander on the launch site system are ensuring every subsystem goes okay. Go for launch.
15 minutes to go until the Shenzhou-19 launches.
Okay, so everything needs to be checked. Okay. So just during the IAC, that the leaders from China Aerospace expressed that China always recognize the sustainability is a very important consideration of all space activities, including that the debris reduction You know that for all China's launch vehicles, including this one, and also other launch vehicles, after we come into orbit and send our payload into orbit, we will release the remaining propellants into outer space, and also discharge the battery to reduce it to the greatest extent the possibility of explosion. So this is a very reasonable measure to ensure that we reduce the
passivation.
Exactly.
Yeah.
And also, you know that to keep the sustainability, you know that we also have already begun to coordinate with other countries, although it may be a little bit earlier, but the possible collision is this lunar space. You know that there are more, as Yan Song had mentioned. Today, the moon becomes another hot point of the space activities of human beings. So there are more landers, orbiters to the moon. Just during IC, I met some private companies, including the Intuitive Machines from the United States. They provide the lunar landers commercially. And, you know, and also other, I can see in the exhibition area, I can see a lot of moon landers, either those from the universities or from the private firms or from the national teams. So today is the right moment for us to coordinate our human space activities in the cislunar space, either in orbit or on the lunar surface. So because you know that we've already found water on the lunar surface, and also potentially in the future we can utilize the helium-3 to solve the energy problem of human beings. So it is very hopeful today we have the more and more chance to adopt the commercial style, a commercial manner in our space activities to provide all kinds of services to deliver goods to the lunar surface, or provide the communications or other services. So today, the lunar exploration is not only the business of national teams, but also more and more private firms engaged.
And Mr. Xu, how important do you think that is to have the private sector get engaged in this? I mean, what's the advantages that commercial space exploration has?
Commercial sectors can provide two aspects. One is financial support to the space program. Another is technical validations to the existing technologies, or maybe new technologies, demonstrations. But they also have a risk because Professor Yang mentioned about the space debris issue. We have roughly 100,000 objects orbiting the Earth orbit with diameter more than 1 centimeter.
100,000?
100,000 is already in orbit.
That
and also,
sounds like a lot.
We have also increasing number of commercial companies that is launching satellites to orbit with mega constellations. All three astronauts you can see on board, they have also the risk of colliding with space debris.
Yeah.
So one of the launching campaign has to do is to calculate the orbit, because they have modelized all the space debris, and they have to calculate very carefully the opening of the space debris so that the astronauts can travel to the station safely. And one of the prominent payload on board this mission, Shenzhou-19, is to install a space debris protection shield on board the station. This is going to involve EVA activities. And later on, we're going to see that installation. So that shield can protect in a degree of the bullet speed space debris hitting the station, damaging the station, leaking the station, or hurting the astronauts. So this is one area that we have to be very careful. As you mentioned about the sustainability of IEC.
What would that look like? What would that space shield look like exactly?
I think it's like a bulletproof panels outside of the fuselage.
Sort of hovering outside, or with the space in between.
The final ignition time has formally released.
Yes, we've got 10 minutes to go.
4 o'clock, 27 minutes and 31 seconds.
Yes.
So that's the accurate time for the ignition.
But
so
it's
very interesting, you know that
almost exactly 10 minutes from now.
Yeah. You know that it is very interesting that the countdown to zero, the definition in China and other countries are different. In China, the zero moment means the ignition time, but in other countries, for instance, in the US, the zero means the liftoff time, the liftoff moment. So it's different for several second interval. So you can always hear the voice during the launch of China when ignition in zero, and the ground team will report the real liftoff time.
So what we're seeing now, the 4:27:31, that's the ignition time.
So that's accurate.
So the launch will be a few more seconds or so following that.
So you won't see fire, after zero, for 1 or 2 seconds, and then there's a fire.
But
so a little
in
delay.
US, you can see the fire just before zero because the ignition is several hundreds ahead of the liftoff, and at time zero, it will lift off.
Is it very precise then, the amount of time? Would they know in advance the amount of time between ignition and actual liftoff? Can that be calculated in advance?
That's very important.
It has to be very careful because the liftoff time is what we call a route parameter that can calculate. It can be used for a route reference for calculation of the orbit. So once liftoff, there is going to be an announcement, the exact timing up to the milliseconds, what time the liftoff. Then,
exactly.
Yeah.
So then after we see the ignition, which was announced there, how many more seconds after that will we then see the rocket actually lift off?
Yeah.
Just 2 seconds. Okay. So it's not a big delay.
The ground team will report the real liftoff time, the real liftoff moment, accurate to milliseconds.
Yeah. After the liftoff, there's a first announcement. You can hear from there's a parameters. It's going to be announced by the control. So there's going to be a series of numbers. So that number is going to be used for calculation of exact orbit in the coming future.
For instance, for this launch, there will be a voice called 起飞时刻动4时27分31秒497毫秒.
Would you like to give that to us in English?
Okay.
That's
that's an example. So that called the real liftoff time is 4 o'clock, 27 minutes and 31 seconds and several milliseconds.
So that would be phonetically similar to
yeah. So that's so every time the same style.
Yeah, but the cruise looks calm and firm, as they call it, then they're ready to experience.
They still haven't
2 of them are first timers.
Yeah, they still haven't put their visor, the helmet on properly, have they?
So you can see Miss Wang Haoze sit nearest to the camera. And already we can see maybe already her face mask has already her face window has already been closed, I believe.
Wait, she's the one that's at the bottom of the screen, or the farther one? She's one at the far
closer
end, right?
to the
bottom of the screen.
Bottom of the screen. Yes, exactly. So as I mentioned, she is 03. Usually the flight engineer and all the payload experts sit in this position. And 02, as I mentioned, is Mr. Song Yingdong.
He's got the parachute button.
Yeah. To control, just not this time, just during the re-entry half a year later. I hope he will also conduct a vertical landing.
Well, that would be impressive. It would be
that
something
would be
to remember
more
for him.
For all the 3 crew members.
And especially for him being his first time up there and then first time return, if you get a vertical landing.
But horizontal, you can imagine you're being strapped by the safety belt to your seat, maybe face down.
Yes, exactly. Not very comfortable.
So if the vehicle, that there is a deviation between the center of his mass and a symmetrical axis. So because of this deviation, usually, in most cases, it will lie down. So that will be much more inconvenient for the astronauts.
So we're looking at some of the conditions right now at the temperature, 3 degrees only.
Yes, right.
But visibility, very low wind speed, right? 0.8 meters per second, actually. Is that low?
Yeah. Actually,
good visibility.
It is deep autumn in Jiuquan Satellite Center, much colder than the night of Beijing. We can see Miss Sun Ye, the very, very close.
Yes, definitely. Yeah. So, 5 more minutes to go till ignition time. And just talk us through what the astronauts will be experiencing during the launch before they reach orbit.
Parameters, and also maybe, as I mentioned, maybe they will already close their face masks. And also,
that's the 5 minutes countdown.
5 minutes and counting.
But the astronauts won't be able to see outside at the first stage. And then after the jettison of the escape tower and the fairing, they're going to have a little window they can see outside. Yeah, see the horizon.
The what called the launch azimuth, or the flight direction of this Launch March 2F is going to the east. and then a little bit to the south. So maybe at the separation of the second stage and the Shenzhou spacecraft, maybe they can already see the sunshine, maybe. And at that moment, they can have the light from the window.
And Mr. Xu, can you give us a sort of equivalent of what it would feel like to be an astronaut during this whole, after the liftoff, you know, especially with the G-force and everything, you know, what would it feel like to us, you know, if we can find something?
If you can imagine you're in a car, in a sports car, and you accelerate very quickly, it's like an airplane or even faster. Then you go vertically, but you're going vertically up with the acceleration. And then that would happen in the first, let's say, 10 minutes. The first 3 or 4 minutes, you get very quick acceleration, and there's what we call a max Q, the biggest time biggest stress that you can experience in the launching.
The biggest stress.
Yeah, and then there's also issues what we call a pogo. Sometimes it go up and down.
Oh,
and
vibration.
Then, vibration. It's a vertical vibration, what we call pogo. And then after like 10 minutes, and then there's a seize of the engine, and then you feel microgravity. You don't feel anything. It's like floating in space. So that's the whole process of launching, I think.
Usually, the thrust of the engines is a constant value. Okay,
3 minutes.
T-minus 3 minutes and counting. But you know that the propellants become less and less. So the acceleration becomes more and more. You can feel more and more G-forces. So that is very normal. So usually the max G-forces happen during the separation of the stage. So that is the reason.
And this pogo stage you're talking about, I guess that's why they need the seat to be so snugly
you can feel
fit
that
to
all
their
your organs will
right?
go out.
Yeah. It's like
to reduce the amount of space that you could be hitting against
it's
a chair.
Big suffering, yes.
You know that Mr. Yang Liwei feels extremely uncomfortable because you know that the G-forces combines with the vibration together. This can never be simulated on the ground simultaneously. So
they can't really prepare for this then, you're saying? If it can't be simulated on the ground, can they
They will have trainings of the G-forces, they will have the trainings of the vibration, but
not
on
together.
The ground, they cannot be combined together.
So then only
but there's room for you improve the rocket itself and make it more smooth.
So really, only astronauts who've made the successful mission to space and back they're the only people who've actually can experience this movement, I suppose, of the launch. You can't replicate it here on Earth so far.
It's out of the Earth.
Okay, please notice it's already less than 2 minutes for the liftoff. And next, as I emphasized, some of the arm connected to the launch vehicle will be unplugged.
So all those umbilical cords, essentially. Yeah. They're looking very tense there. This is the control center in Jiuquan.
We're going to have countdown at any time.
So we also have cameras mounted on these arms to monitor the separation position, the unplugged position. So today we have more measures than before to ensure the safety.
Oh, how nervous they're feeling. Okay, this is the 1 minute countdown now.
T-minus 1 minute and counting.
That means everything has to be in green light. Nobody has to press the red button.
Don't touch anything.
Yeah. The number of systems that has to work together.
But they're so practiced at this now. You know, they're so experienced with this whole process.
All the
40
arms
seconds.
untouched.
Thirty seconds to go.
So the transfer of power supply also accomplished.
So the rocket is on its own.
Maybe the astronaut will salute.
Yeah, normally.
I feel the tension. 10 seconds. 5, 4, 3, 2, 1.
Salute. The report of the real top time. And the tower is cleared now.
I counted as well after the ignition, about 2 seconds, yes.
So
that's it. That's a long March carrier rocket.
Successful liftoff. After about 2 minutes, we will have what Yan-Sun mentioned, the first separation.
Right.
The jettisoning of the emergency escape tower.
This you see is a strap-on booster.
Yeah, exactly. So this is the camera mounted on the core stage.
Yeah.
We can see 2 of the 4 strap-on boosters, 2 of the 4 side boosters. So as I mentioned, each have 1 engine.
Looking down.
I think we're hearing.
Yeah.
Really.
Looking back.
It's a nominal tracking.
Now we can see that on the right of the screen is the camera mounted inside the re-entry capsule, and on the left is what the camera, as Yan-Sun the camera mounted on the core stage.
During being at the Beijing Aerospace Control Center.
Just during Yibing's description, we've already seen the successful separation between the end stage and the Shenzhou spacecraft. And now you may notice that the Shenzhou spacecraft is already in the sunshine area. You can see the beautiful curvature of the horizon of the Earth. Very beautiful.
This is the camera outside the capsule.
Yeah.
And so soon we'll be expecting the solar panels to open up.
Yeah,
right?
unfolded. Will be extended within several minutes.
That marks the success. Yeah.
Although we don't usually hear the announcement from the control center of the
with the commander of the launch site system. Now you can see the camera on the propulsion module, which can monitor the unfolding procedure of the launch solar panels.
We just heard some various reports there.
And also, as I emphasized, you can see the beautiful curvature of the Earth's horizon. Okay, unfolded. Each of our solar panel wing have 4 pieces. The Shenzhou spaceship.
How many solar panel wings does this have?
2 wings. Each have 4 pieces.
And then we can see the Shenzhou-19 crew in there eagerly awaiting. So we expect the 2 crews to meet by midday Beijing time, right?
Exactly.
Meet for lunch.
Yeah.
The 5th
lunch date.
The 5th rendezvous of different crew in orbit.
Yes, the capsule itself has to find the sun so that the solar panel can be driven by a system called SADA to face the sun to generate maximum power to provide the capsule with electricity.
It finds that automatically?
Yeah, it has a sensor.
And the orbit maneuver to chasing the Tiangong space station will all be done automatically.
We're hearing that they're saying the panels are rotating normally.
The ground staff report, as Yan-Sun has mentioned, the SADA working normally. Tianlu is the name of the Tianlian data relay satellite.
We're talking about the tracking there.
Yeah. Now you can see it's already in the daytime. You can see the Earth is so bright.
Oh, I was wondering what that was actually. I wasn't sure.
It's already above the Pacific Ocean.
They find the sun.
Sunflowers.
So it's another day for them.
That's the Shenzhou-19 crew speaking to the command center. Oh wait, the other way around.
The voice of Mr. Cai Xizhe.
Report on the health conditions.
That's the Shenzhou-19 crew speaking.
Feeling good.
That's a classic line, isn't it? Yeah, we're feeling good.
Obviously, he's very calm. Is
this the little window that there's
they can open their face mask?
They can. Okay.
Because this moment, the inner atmosphere inside the cabin is in a normal condition.
There, they just open it
not
up.
hazardous to the astronauts.
What sort of temperatures is inside this capsule right now?
In room temperature, usually very comfortable for them. Maybe 20, maybe 25 degrees.
Yeah. But when they open up the that helmet, the visor, would they feel a change in the pressure?
No. It's adjusted to the human adapted conditions. Yeah. What we call life support system on board the capsule.
Okay, both the space tracking ship Changjiang 3号or the Yuanwang 3 tracking ship and also the Tianlu or the Tianlian data relay satellite have normal communication link with the vehicle. So we have redundancy measures, both from the sky and from the sea.
So this view we're looking at right now on the screen, so this is a camera
mounted on the Shenzhou spaceship.
And that
outside
bright orb is
the bright one on the top right is the Earth.
That's
with cloud.
Really fascinating view.
Maybe it's all right, not cloud. Maybe it's because
White
it is too bright. It's just because it's too bright.
Yeah.
That's not a view everyone gets to see.
It is overexposure of the camera.
I hope we can go there and see it.
Maybe with these privately, operated spacecrafts.
You will be the fifth batch of
As Sun Ye was saying earlier, that the frequency of these launches now, these manned missions, every half a year, it's impressive, isn't it?
Yes, to maintain the permanent presence of human beings on board the station, you have to do that in rotation every half a year. But astronauts do have longer times they stay in the station. One of the longest one, an American, spent almost 2 years in the station. But when he came back, he said, I went to a foot massage. And the foot massager said, I've never tried a foot so tender.
Wow.
Now is a video. Oh, this is a 3D animation. So you can see, although it is a 3D animation, but it is real data driven. So the status, including the status of the panels, represents the real condition.
实时轨道与遥测数据监视判断，神舟19号飞船已进入近地点高度200公里，远地点高度362公里，倾角41.5度，周期1小时30分钟的预定轨道。太阳帆板展开，飞船工况正常。
The spaceship is operating normally, the astronauts are feeling good, the panels are open, operating well. Pretty much as expected, everything just went.
But that apogee and perigee, it's in the elliptical orbit. It's going to be having another maneuver before it's ready for rendezvous.
It has a very small eccentricity. The perigee is 200 kilometers, and the apogee, or the highest point, is 362 kilometers.
And if you put that in lay terms for us, the apogee and the perigee, we're talking about...
It's like an elliptical orbit. It's in relative to Earth. Yeah.
Okay.
Yeah. So it has a near Earth point, and it's also far Earth point. So that makes an elliptical orbit.
Elliptical.
The highest point is the station orbit.
So the commander will announce the success, and we will see the big red screen.
Yes, we'll be hearing it very soon.
Like my tie.
Officials, comrades. Based on the flight data and report from Beijing Command and Control Center, the Long March 2 Y-19 carrier rocket has sent Shenzhou-19 manned spacecraft to the preset orbit. The solar panel has been unfolded successfully and is functioning well. I now declare the launch of Shenzhou-19 mission a complete success. Thank you.